Hi everybody, this is OS Management at the Edge with SUSE Rancher. This is the 12-11 session, and this is basically a continuation of the session 1143. That was the more theoretical part of how we think OS management should be done with SUSE Rancher. And in this session, I will go into the depth, show you a demonstration about how does it work, what you need to do basically to get everything working. So I'm going to do a short introduction first, and then the demonstration after that of the whole environment. So first I'm Jurriën Bloemen. I'm a pre-sales consultant at SUSE. I work here right now, more than 3 years at SUSE. I love technology. I like new things, and one of the things is this new part that we're working on. So the demonstration is we're basically going to show how it really works. Be advised, this is all really early alpha stage everything. So yes, you can play it with it today. Yes, it can break in your situation, but yes, it could also work perfectly in your situation. And today I'm doing it in a controlled demo environment for you. So let's dive into that, switch the screens, and see what it looks like. So when you want to set up OS management with Rancher right now, keep in mind, I'm saying it again, it's an alpha state, so everything that I'm going to show you today could be changed in the future. Of course, you can expect from us that we're going to make it very easy. So there are a lot of steps also on the command line that you have to do right now, but it will just give you an idea where we are right now and what we're going to maybe present in the future or how it works today. So one of the first things you need is a Rancher management cluster. We're going to use the local cluster for this because that's where the Rancher management software is running on. This Earth-01 cluster we're not going to touch in this demo, but it was added already to my management cluster. Next to that, you need a build host. I already set it up with a slash on it. And one of the first things you need to do is add a repository to it. So let's become root. And it's here in the history, I believe. Yes, here it is. So we're going to run this command. Okay, this is already added by me. For testing, of course, you need this repository because we need a package from that repository to install. In this case, it's the Rancher OS operator charts. That is already installed. So when you go back to your normal user, we'll go to the directory user share Rancher OS operator, and we got a couple of files over here. A couple of things we need to do first is, of course, get in the credentials into the kube config. So from our local cluster, we need to copy or download the kubeconf file and get that into our demo server in the .kube directory, and then the config here in this file we need to, in my case it's home Jurriën .kube config. So the Helm and kubectl knows which cluster to connect, and make sure it's the local cluster. So we're going to perform these actions on the local cluster. So one of the first things that we then going to do is install the Rancher operator chart here via the Helm command. What we're going to do, we're going to make a namespace, Kettle Rancher OS operator system. We're going to install it. We're going to create the namespace, of course, and we're going to use that file, to get it into the Rancher management cluster. So this is also. So when I hit enter, it will install everything into the Rancher management cluster, and that then should be fine. So the next step is that we need to make some kind of a machine registration template. We're going to use the machine registration .yaml file, and if we're going to look into that, there are some basic instructions here where we define, okay, the device where we're going to install the whole OS image is going to be the VDA, because I'm doing it into a virtual environment, but in a normal situation that will probably be SDA or an IDA interface. For now, we're going to use the root user with the password root just for easy stuff, for easy management, of course. And we're going to apply this one, kubectl, kubectl apply -f machine registration. This will apply it to the ransom management cluster. So when we did the installation with Helm and we added or applied the machine registration, if we go to the local cluster, you should see under the more resources, you see here the RandomOS Catalio, and we see the machine registration over here. That's one piece, and we had a default one. So if we open that one, you see, the standard variables here, like it's going to be installed on the VDA with the root password. And what is very important is that we use this machine registration token. This token is used to do a callback to the ransom management cluster from the operating system that's running on an edge device. And it uses this URL to connect to, so that it says, hey, I'm alive. It will appear in the inventory of the machine inventory, and then you can decide what you want to do with it, add to which kind of cluster, what the role of that node is. So this is very important. Right now, one of the first steps you need to do, it's a little bit of a chicken and egg. You need to download this file into your build host, and I already did that for you guys already. And you need to add the line, how the hostname is constructed. In my example over here, this is still not really working, and probably in the future this will disappear or will be automatically done. But for now, we need to add this to the file, because the OS needs to be configured with a unique host name, so that we can start up multiple machines next to each other and add them to a cluster. So if we have done that, the basic preparations are ready right now, and the next kind of step is that we gonna clone some stuff from a GitHub repository, and we're gonna build a latest image, and that will be based on SleeMicro. So before we can create an OS image, I forgot saying you also need to install Docker on this image build host, because we're going to use Docker to build the OS image. We need to clone a Git repository. So let's make a Git directory, go in there, and run this git clone command. This will get the latest states from the files from our repository. And with this information, we can start building our OS image. One of the first things we're going to do is run the Docker build command. Well, let's first take a look at the Docker file, because we're going to do some stuff here. So we're going to download from the registry from the OpenSUSE our SLE 15SP3 render image. This is the SleeMicro 5.2 image. That is still in beta, and we're going to install some stuff in there. So we can use it within our environment. Take a look at this, if you have some free time. But we're gonna change the image a little bit, so it's more convenient how we would like to use it. So we're going to use Docker build. So this is going to create an image. It's going to download some stuff. It's going to take a little while, so probably going to speed it up anyway. This is going to do some stuff in the background. So I fast forwarded a little bit, so it's a little bit quicker. But now we have successfully built an image. And this image we're going to use to do the elemental injection and with the file stuff, with the unique machine registration file. Right now, because I think it's a little bit handier. We're going to create a Docker tag. We're going to use this ID, and the label we're going to put on it is node image. And the next command that we're going to run is it's basically that elemental image. ISO image build. We're going to specify the tag, so that is node image, and it's going to be an ISO file, and we want to incorporate from our home directory that machine registration file. Here it is. So we're going to run this again, and it's going to take a while, so probably going to speed that up. So the image creation is done. Now we need to get the ISO file out of the Docker image. We have a command to do that, and this, of course, will be much easier in the future. But this is the command that we need to run, and the number over here is the image that we have altered with the image or the elemental image build. You will see that tag number again. So you put it in here, you run this command, and it will copy the elemental.iso to your local file system in here. Here it is. And this is basically the image that we have built with all the stuff in there, how to do the callback, have the whole file system arranged and that kind of stuff. That's all in there. This is ready to go to deploy on a system. So we need to do, before we can add basically systems to Rancher, we need to create an empty cluster. So we're going back to this directory, which has been created by installing the package earlier, and we have a create cluster YAML file here. And in this instance, it's going to be named SLE microcluster. Well, we just leave it like that, and we're going to install K3S version 1.21. And again, we're going to apply this to Rancher, create cluster. So if we're going to look into Rancher over here, we should see that we're going to have now an I need to reload my dashboard. And we have the SLE micro cluster over here, waiting to be provisioned. So there needs to be at least one node there. So the next step is to copy the elemental ISO file to your, well, in this case, in my case, to my virtualization platform. And from there on, I'm going to start the installation. So let's go to the virtualization platform. In my instance, I'm going to use Proxmox, and I already created a node over here. Let me double check some settings. If it has a hard drive, everything looks perfectly fine. I have the elemental ISO already connected to this virtual machine, and it's gonna boot also the appropriate stuff. So let's start the console over here. Start the machine. Yes, please start that for me. And this is basically, let's stop the timeout. This is basically step one, what we're going to do. So we're going to install the Rancher OS on this machine, or the operating system on this machine based on SLE Micro. Or at least it's going to, install that on the file system. So let's do that. It's going to boot up. So it shows a lot of normal kernel information on the screen. Let's give it a while. So here it is. So what we now can do is do a journal following of the ROS installer. And here you can see that the installer is already busy with copying or it's creating the file system, and it's copying the active image, and it's installing the grub on it, and at some point it says it's finished, and then it's going to restart the operating system. Now, rebooting in 5 seconds. So let's wait for that. Now you see the grub that's installed, and you see also the fallback and the recovery possibilities to the other partition to it. And now it's booting from the hard drive. Well, when this is booted up, then the system will do a callback and say, hey, I'm available for whatever task you want me to do. We should see it then back in the ransom management cluster, but let's wait until it has booted up. Here we go. So now if we go back to Rancher, still this one is still pending because we haven't assigned the system to a cluster. But if we go to the cluster management over here, cluster management local. No, I need to go to local here. I need to go to more resources, and we should see a machine inventory over here, and that's right. That's correct. So this is the machine that I just booted, and now we can start configuring the system to say, okay, what is your role and to which cluster you need to add. We're just going to edit the YAML. The cluster is SLE Micro. For this instance, for this demo, we're going to give it the role server. At the moment that I am going to hit save, you're going to see the system. Let's open the console. So if you remember from the beginning, the password is root. Just open this, and it will start automatically with firing off the installation and everything. So we press save over here. So let's go back to the console. Here it goes. This will now install the appropriate stuff like K3S, and then it will automatically connect to the SLE Micro cluster. So this is probably going to take a while, so I'm probably going to speed it up a little bit. And we probably can have a look in, still on pending over here. Oh, you see here, it's now bootstrapping a node. So it has finished provisioning the cluster with or at least this node, adding it to the cluster. So here you can see it's running. It's the version that we have specified. So this is how you create, do a callback, do OS management with edge devices. And one last part that I want to show you is we also have the way to update your operating system. So if there's a new version of your operating system, you're going to do the building of that image the same way as before. and you put it in the registry, and with the OS update YAML, you can specify, okay, this is the registry where it's located, this is the image, put on the latest image to it. Right now, of course, we need to change this to SLE micro. I know it's complaining. Um, uh, and then if you save that with the correct information, you apply that, it will automatically update the operating system that's running yeah, underneath the K3s installations within that cluster. So this is basically what I want to show you. I know, there's still a lot of stuff needs to be done, needs to be fixed, needs to be changed. Yeah, it's all in alpha stage. So yeah, we hope to hope that we're gonna change that in the future, make it more easy to work with. But yeah, it's still development in progress. So bear with us, and yeah, you can expect a really good end result in the end. Having a really easy to use OS management for example, edge devices, but of course you can also use it within your data center. In this example, it's edge devices, of course. So I hope you enjoyed the demonstration. Thanks for tuning in into this session. If you need to know more, reach out to me, contacting me via my email address or in another way, and let's talk a little bit more about OS management at the edge. Thanks for now, and have a great day.